To test null mean 100 versus alternative mean not equal to 100, a simple random sample of size 16 is obtained. Okay, compute the test statistic. So since we are testing means, so test statistic will be done through t-stats. Sample mean. So stats, t-stats, one sample summary. So sample mean is x bar, 104.4. Sample standard deviation is 8.1. Sample size 16. Okay, 100 and not equal to 100. So $2.173. If the researcher decides alpha equals 0.01, determine the critical values. So remember, this one is not equals to, so it's two-tailed. And in two-tailed, the way we do the critical values is we do the in-between, and we do 1 minus alpha for the area. So 1 minus 0.01 is 0.99. And we will use T calculator since we are in the T arena. So T calculator in between area is 1 minus 0.01 and sample size is 16. So where is the T calculator? Stats calculator T. So degrees of freedom will be 16 minus 1, so 15. We'll go in between and 1 minus 0.01. So remember, two tail is the only one which is done this way. For left and right tail, we just put this area in the tail and go left or right accordingly. So 1 minus 0.01 is 0.99. So negative 2.947 and 2.947. So it was two tail, and this is the one which has two tails. And let's see. So what was the p-value across this one? So the p-value was 0.0462, 0.0462, and alpha 0.01. 0.0462 is bigger than 0.01, so you do not reject. And when you do not reject, it means that you are not in the rejection region. Remember, the rejection region is the blue region. So since you do not reject, so you are in between the two values because you are in the white region. So will not reject. Yeah, there is not sufficient evidence to reject, which means you do not reject. Since the test statistic is between the critical values, right? It is not in the rejection region, but you're here. Okay, test it. Again, we are testing means. So do you reject or fail to reject Oh, so here they've done the calculation for us. They give us the p-value. P is 0.0376, which is less than 0.05. Remember, level of significance is alpha. So 0.0376 is less than 0.05. So you reject, because P is less than 0.05. P is less than alpha. Okay. What about the 0.02 level? So 0.0376 is bigger than 0.02. So you don't reject this time because P is bigger than 0.02. Okay. Several years ago, the mean heights of women 20 or older was 63.7. Suppose a random sample of 45 women today result in a mean height of 64.4 inches. So several years ago, it was 63.7. So this is the value you will use in hypothesis testing, because the other value, the 64.4, that is just for a sample of 45 women. Suppose for a sample of 45 women, the resulting mean is 64.4. So in the hypothesis test, you don't use the sample value, you use some other kind of default value, which in this case is 63.7. So that should be the null. And then we are testing state the null an alternative to assess whether the women are taller today. So we are testing whether today the height is greater than 63.7. So this one has equal to 63.7 and greater than 63.7. Okay. P-value is 0.07. So 0.07 and alpha is 0.1. Okay, so right now they're just asking what the p-value mean. So remember, p-value, we did a couple of problems like that. So it's the probability of obtaining a test mean height greater than or equal to the test statistic. So the p is 0.07, obtaining a sample height of 64.4 inches. No, it's going to be the p-value. Okay, mean height of 64.4. No, it's a 63.7 that you're testing. Sample mean height of 63.7 inches or taller. No. Okay. Population is the 63.7. So population is not 64.4. So sample is the 64.4. Remember, sample is 64.4. Obtaining a sample height of not exactly is never the choice here. Sample mean height of 64.4 inches or shorter. No, we're going taller. So 64.4 inches or taller, right? From a population whose mean height was 63.7. And since P was 0.07 and alpha is 0.1, 0.07 is less than 0.1, P is less than alpha, so we reject the null, and when we reject the null, then there is evidence.